Well, greetings everyone, welcome back to the Bass Blaster Audio Tech YouTube channel. And this video changes things up a little bit. While I wait on the parts for my Chrysler Infinity deck to arrive, I'm going to do something that's been in the back of my head for a while, but I've never done it. I have a bunch of, aftermarket single din head units. I just want to make a quick video of a detailed teardown, because there doesn't seem to be many out there. So, this video is going to be pretty simple. It's just going to be a straight teardown of this. And mainly, we want to look at the power amp in this thing. Because this thing's got a pretty chunky power amp. It's rated for like 22 or 23 watts by 4 at 4 ohms. Clean power. This has got a heatsink that goes all across the back. And believe me, it gets hot. Even just running 2 4-ohm speakers. It's clipping the hair. That's about clean. Right. So enough playing around with that. What we have here, this is from mid-2010. This is a Sony CDX-GT240. This is the one that came in my truck when I got it. I think it's already quite warm. And so we're just going to do a quick teardown of this thing. So, we're going to pull out our harness. Get all this stuff out of my way. So to start, we're going to want to pop the face off. Just press the button, kind of wiggle it, and it pops out. A lot of Sonys are that way. Now we have our plastic trim ring. We're going to want to take this off. Don't be like me and forget, but you are probably going to want to get a small flathead screwdriver. This is just to push the plastic release pins, so the face will actually come off. Alright, there's a ring. Set that aside. Now we need to remove the, I don't know what this is actually called. Its cage. We'll remove its cage. Slide the cage off. Set it to the side. Right, so now, this is when we start to get a little destructive. Grab a small Phillips screwdriver. There's a couple screws here in the front you're going to want to remove. I don't remember exactly which ones. But I had this thing apart about a year ago because I was curious, and I've forgotten what chip is in it. I'm going to set these screws aside. These are short, fine threaded. I think you take all 4 of these screws out. No, you don't. No, you don't. These smaller ones here, keep those attached. They hold this thing, which holds your face on. And I believe they come out with this front piece. Now we have more plastic clips. Just kind of lift it and kind of pull on it so it comes out and doesn't reseat itself. Damn it. And see, this is its own part. So you just, and if you do push it in, shove your screwdriver in it, solved. Set that to the side. So now it should look like this. Next, this top piece comes off. So we have one black screw here, which is being marked with an arrow. The screw is the same as the 2 we took out in the front. Now I got that one screw out, this whole top will kind of pop off. I like to just stick a screwdriver in the gap in the back and just gently kind of pop it up. It's friction fit here on the side, both sides. There's our top off. Set that there. Right, now our CD player kind of lifts up. It's its own little thing. There's a screw here and a screw here. I'll pop these out. These are also the same as what's on the top and the front. So far we can't mix any of them up. Alright, so with those two screws out, your entire CD mechanism will lift up and pop out. See here, it just sits in a header. CD mechanism. So if this is your issue, here's your CD player. Not really much to see. Set that over here. And now, we're into the good part. Let's take a closer look. Right, so here we are. It's pretty standard, just a single layer PCB. Here's our reverse polarity protection diode. Can't really see it. We have a noise filter and of course the filter cap coming in from our main harness. Now you got to give all the people that design these single DIN units some props, because these things are so amazingly complex. Look, here's a crystal which isn't even set down on the board right there. So here's our power amp. Let's see here. It's labeled IC705. Let's see if we can get a close-up with the camera of what the chip actually is. Look at all those pins. You can barely see. It is a TDA 8588A. Let's head over to the datasheet and see what that brings. Look at that heatsink too, all along the back. This is quite the impressive chip. It is a 37-pin device. Let's go back to the top here, and this is 2010 or so. This was probably one of the first of its kind. Full digital bus control. Can drive a 2 ohm load with a battery of up to 16 volts. Can drive a 4 ohm load up to 18 volts, which is pretty much all of these quad channel TDA chips. They all go up to 18 volts. You can actually get a pretty good bit of power from them doing that. It's got all the fancy goodies. Everything you'd expect. Programmable clip at 1 or 4%. Soft thermal clip, huh? Low battery detection. How's that work? Oh, digital bus control. Some more other stuff, pretty generic. But it also has, apparently it has 4 regulators built into it. Yeah, right here to control like microcontrollers and shit. Because you're going to need some kind of a processor if it's controlled by a data bus. This is that square wave stuff you never see in the real world. 2 ohms, 14.4 volts, a 2 volt square wave on the input, 87 watts, 15.2. Where do they get these voltages from? I moved the camera closer as I realized how bad the screen looked. But look, there's 5 voltage regulators in this thing. All kinds of switches. I don't even know what half this shit's for. What is a backup switch for? Data interface. Here's our outputs. Look at that. Each channel has its own diagnostics. All 37 pins. And the fact that Sony was able to put this on a single-sided board with minimal jumpers. Okay, this is all digital shit. Let's see. Yep, where is... I don't even understand any of that. I want some charts to see what our real power output is. 4 ohms, 14.4 volts, 0.5% THD, we can expect 21 watts. 10% we can get 28. 2 ohms, 14.4, 0.5% we get 41, 10% we get 55. 4 ohms, let's go with line 3, which would be 0.5%. So at 18 volts into 4 ohms, looks like we'll be busting about 32 watts, I'd say. 10% will be like 45, and then max, which you'll never see in the real world, is just creeping on 70. Ah, here we go. Here's the same one for 2 ohms. So 3 is 0.5%. 2 ohms is only rated to 16, which gives us almost 50. However, if we go up to 18, we'll be about 60, 61, 62. 10% THD will be doing like 85. The reason they probably don't spec it at 18 volts is heat dissipation probably becomes an issue at that point. Microcontroller, aerial motor, amplifiers, display, mechanical drive, mechanical digital, audio, microcontroller. all from a single package. That's why this thing has so many pins. Something I forgot to show. Look at the board layout for this thing. This is the top side, and here's the bottom. I'm looking, I do not see any jumper links. No, I don't see any jumpers at all. I see some surface mount parts, of course, but no, I don't see any jumper links. Okay, so to get the main PCB out, it's a little more tricky. We have to unbolt. So let's see, it looks like you have to unbolt everything from the heatsink, but no, you can actually just unbolt the heatsink from the chassis and it'll come out as one thing. So that's what we're going to do. Now these are where the screws get different, I believe. We have one screw here. Well, it's a different color. It might be the same thread. Is it? These silver ones are the same thread as the black, but they're a little bit longer. However, you can't get them mixed up because the silver ones are only here on the heatsink. Okay, so the heatsink is free from the chassis. Now there are 3 screws on the main board. Now you have to be careful because 2 of them are grounding screws. You can see they clamp down to these links. Now these screws you also can't mix up because they have a wide head on them. But they do share the same thread as all the previous, but again they have that wide head, so. Right, so with those 3 screws out, the whole unit will just lift up out. On the bottom of our chassis, we have a insulating piece of plastic. This just stops the bottom of the circuit board from shorting out. So that's all it is. We'll set that aside. And here is our main PCB. Well, we've seen the top of this enough times. Now let's check how Sony has routed 37 pins of this TDA chip. I am already impressed. I'm just noticing. What? I've just realized. There's no tuner on this thing. Though there is. It's all in one single chip. Nice. Let's see if we can get closer to our IC here. I don't even know where to begin on this thing. You can see where our speaker goes. It's all tin plated. It goes over to our header. You can see where all the jumper links and some diodes go. Data pins kind of scatter around the board. I'm not tracing this out at all. There's the header for our CD drive, so some of those pins off of that thing will probably go to there. All the service mount parts around it. Then because it's a single-sided board, if you flip it over, there's nothing there but some diodes and of course the jumpers. Impressive. And of course you can tell this is a kind of an old unit because it still uses a full-size fuse. Just a normal 10 amp. However, if you want to run this at 2 ohms, you might want to up this to a 15, maybe 20. So what is it rated for? Like 45 watts into 2 ohms. That comes up to 4.7 amps. So let's say peak will have about 5 amps a channel. So there'd be 20 amps coming out of that chip. Yeah, I think heat dissipation would turn into quite the issue. I think I'm gonna go pull out my 2 ohm speaker and have some fun with this. I'd pull the heatsink off, but all that'd be here is the back of the chip and your bare connectors. So instead, I'm going to go ahead and start reassembling this thing, although I will put the fuse back in it before it gets forgotten about. Okay, so, where did the bottom of the chassis go? Here it is. Goes this way. Then our board kind of just... I cannot stop looking at that. That multi-watt package is fucking impressive. I love car audio stuff for that. Okay. kind of slides in there. Like that. The board sits in locking pins down here, so you can't get it in wrong. Right. So for the board, we need the 3 wide head screws. Make sure this screw and this screw are down a little tight because those are ground screws. Now I'm going to reattach the heatsink to the chassis, which is the only silver ones. If you want to get real anal, you can put a little bit of thermal compound here and here. So when the heatsink clamps to the chassis, it kind of draws even more heat. But I like how with these automotive head units, the heatsink is usually nothing more than just a straight chunk of aluminum. Like there's no fins, it's just a block of aluminum. I know that's how Pioneers are. My God, those things get so unbelievably hot. Next is our CD player mechanism. It's all one little happy loop. So kind of, again, they've got these little locking pins and slots, so our CD mech will just drop right in and then press down into the connector, which it has. Now, you will kind of have to get your thumb and push the mechanism all the way down or the screw won't go into the hole. It kind of binds up. Like this here, kind of just get your finger and push it down like that so the screw will go in. Next is our top. Line up the tabs on each side and it just presses down. Make sure our top screw hole lines up. Next is this front piece, which has got the thing that pops your face out on it. Line up the tabs on the side and just make sure it's, whoopsie, make sure it's straight on and aligned. Which can be kind of tricky because it's plastic and it does like to bend. Okay, there's that side snapped in. Okay, it's kind of tricky to get it on this side because you kind of have to push it down. But once it clicks in, like this side's not in yet. Yeah, you also got to watch this pin and this pin. You see it kind of goes underneath our top metal. It has a little flat bit that slides under. You have to make sure you get that or it won't go down. Just like that. We're going to get our last 2 screws and stick them back into these 2 holes here. Now we're going to put our trim ring back on. This will just snap back on like that. This would be a good time to wipe the dust off of it if there is any. Now, get our face. And then we'll put the cage on. Now, I'm not using the cage, however, I'm going to put it on just so, you know, I don't lose it. And there you go. That is how you completely disassemble and reassemble a Sony CDX-GT240. So if you guys just came for the teardown, that's the end of the video. I'll see you next time. However, if you guys want to see me torture this poor little guy and hook a 2-ohm speaker to it, stay tuned because, well, that's what I'm about to do. So today on my fuck-ups, I just spent about the last 20 minutes scoping this thing, playing with it, and running my yap until I realized I'd never actually pressed the record button. But basically what I'd done is I bitched that my power supply cable is too small. The 22 gauge isn't enough for this stuff. At 4 ohms, 16 volts, before, right at clipping, because this is a stepped volume. So no clipping. Clipping, I was reading 25 watts exactly. I don't know if that's right, because my understanding was with a bridge output, you have to have a differential probe. But with a cheap scope like this, where the ground is essentially floating, that may not be true. I don't know. There's not really much info on it online. Ow, ow, ow. Jesus Lord, don't touch the back of this thing. But I'm pretty much done playing around with the 4-ohm speakers, because I wasn't recording, so I don't feel like doing everything again, but I just gave it the rundown. I'm going to pull out the factory Ford subwoofers. Those will be the fun one. Why do I keep doing that? Right, so we have the 1.2 ohm by 2 factory Ford 8-inch Shaker 500 subwoofer. I have another one too. I might dig it out, but where the fuck am I going to put it? I have the windings in series, so it's probably about 2.5 ohms or so. So I'm going to pull up another tone generator, turn it up until it clips, and see about the power we get. What did the datasheet say? 16 volts, 2 ohms, what was it, like 45 or 50? Well, we're at 2.5 ohms, about. So I'm not expecting the full power. Okay, the poor camera probably got the shit shook out of it earlier. I wasn't looking at the screen. That'll be funny when I look at it in editing. Right, 55 hertz tone. Okay, so the top rail's starting to clip. It does soft clip. We're getting 9.86 volts. Righto. That comes up to 38 watts. That sounds about right. I can't think of anything else to do to this thing.
All I want to do is touch a platinum black and celebrate. All I want to do is keep my niggas out the yellow tape. All I want.
Okay. I can't think of anything else I can possibly do to... As I was saying, I can't think of anything else I can do to torture this poor guy. My power supply is probably also starting to forgive me right now. But, if you guys enjoyed this video, which is mainly a teardown, this fooling around with it was just to fool around, feel free to leave a like, comment, and subscribe. I may have another head unit. I have a JVC I might tear down. I'll also have another factory Chrysler. But, feel free to leave a comment, subscribe, let me know what you thought of the video, and I'll see you guys in the next one. Bye for now.